In this video, we want to delve much more into how this formula is obtained, how that formula is obtained. So let's proceed. So here you realize that to understand this, as we said in the previous, first of all, let's consider an arrangement in a line, and there, let's say we want to arrange ABCD in a line. So let's use that as an example. You want to arrange ABCD in a line, and then anytime you want to arrange, since it is linear, you just have to take 4 factorial. So so we have A, B, C, and then D. So if you want to get the number of different arrangement, please, that's the difference. So if you want to get the number of different arrangement for a linear permutation, just take for a number of the number of different arrangement for distinct letters in a word or object. It means that you have to take the n factorial. You have to take the n factorial, the total number factorial. So here A, B, C, D, 4. So 4 factorial. That's what you can do to basically get it. But here we are dealing with circular permutation. So now imagine taking a linear arrangement ABC and join it, and as we said in the first video, for any circular arrangement there are n linear arrangement that produce it by cutting circle at different points. Now this is what it means. We want to obtain that where permutation, we want to get this equation where permutation is equal to, we want to understand this equation is equal to this one. So basically this is what we can do. Let's say we have a circle. So we have A, B, C, and then D. We can join them end to end, and then we can get it around, let's say around a table, a circular table. Now we can get 4 different linear permutations from this. How do we do that? We can cut the line, or we can cut the circle at this side. If you cut the circle at this side, or if you cut the circle, let's cut it at this side, we get A, B, C, and then D. That will be the first linear arrangement. Now you can try this at home. Get 2 or 4 different objects, tie it around the rope, hang them around the rope, and then put them in circular form. If you cut this side also, you get B, C, D, and then A. This is another linear. You see, just one circular permutation. We are getting this, how many? 4. We can get 4 out of it. And then if I also cut this end over here, I get C, D, A, and then B. And then if I also cut here, I can also get D, A, B, and then C. So you realize that out of this one just single circular permutation, we are getting 4 linear permutations. And just remember, this is how it is done. Always anytime each letter begins, a new permutation is formed. So A began, and then a new permutation was formed. B began, C began, and then the same in that accord. So that is how we can get 4 from this. So here it means that if these are the 4 linear permutations that we can get, this, and then that. So it means that we can basically, therefore, to find the number of unique circular arrangement, we divide the number of linear arrangements, the linear arrangement, that's factorial, by the number of times each unique circular object is counted in a linear list. So what we do is that here we have to, so for circular arrangement, what we do is that we just have to take the total number. How many? There were 4. So we take the total number of the letters, the object that we are considering, factorial, over how many distinct linear permutation did we obtain over that, the number of distinct linear permutation that you are going to obtain. If it is 5, you get 5. If it is 4, you get 4. So over 4. And then you realize that n factorial is equal to n into bracket n minus 1, then times n minus 2 times n minus 3. Always the next one is subtracted, the next object or the next number is obtained by subtracting 1 from it. So this is factorial. So n and then n will cancel. So that is how come you obtain the circular motion. That's how we obtain the circular rotation or circular permutation as this. That's how you obtain the formula as this one. So basically, anytime you have a circular arrangement, there are a number. So if there are 5 objects, so let's say that we have 4 objects, like as we illustrated, you realize that there were 4 objects arranged in a circle, and with these 4 objects, you realize that there are 4 different linear. If there are 5, there will be 5 different linear arrangement that can be made out of that one circular arrangement. So that is how it is done. So you take the total, the factorial of the total over the number of linear arrangement that can be obtained. So basically, this is how you obtain the formula for circular permutation. Thank you very much, and let's move on to talk about other forms as well. Bye.